Hello everyone, this is simple math for you. Our lesson today is about perpendiculars and distance. As many students have requested this lesson from me, so upon your request I am recording this lesson. أهلا بكم من جديد في simple math for you. ودرسنا اليوم عبارة عن إيجاد المسافة بين خطين. Why it's perpendiculars? Because there is an infinite number of lines that intersect a line and pass through a given point, not on a line. However, when determining the distance between the line and a point, you must find the shortest distance between the two lines. This distance is length of segment that is perpendicular عمودي to the line through the point. For example, this is a point and this is a line. If you are asked to find the distance between the point C and line AB, you cannot find the measure of these dashed or dotted lines. The measure that we are looking for is only this one, is the perpendicular distance, is the perpendicular segment length. So our objective today is to find the distance using perpendicular lines to find the distance between a point and a line, And the second objective will be finding the distance between two parallel lines. So if I given a line and a point not on the line, then there exists exactly one line through the point that is perpendicular to the given length. Of course, here, if you are finding here any perpendicular segment between C and line AB, there is only this one. There is no more than one perpendicular segment, and we are looking for the measure of this segment, or the distance between the C and the line. So this is a real-life application, and we will start by this exercise or this problem to understand what do we mean by distance. Javier wants to build a shed on his property. This is brown shed here. According to zoning laws, the shed must be at least 20 feet from its property or his property line. Javier knows the points A, B falls on his property line. So we have here, in math point of view, this line passing through 2 points, A and B, with the coordinates seen. If Javier plans to build the shed behind his house at point C, so this is point C that we are finding here, where he satisfies, question, will he satisfy the zoning laws? يعني, will the distance be more than or equal 20 feet? If yes, how far away will the shed be from Javier's property line? Each unit on the coordinate plane represents 1 foot. So we have here to find, actually, we are looking for the distance between the C and this property line. As you see, all these will not work. We are looking for specifically one. You are not drawing accurately, but just to see that this is the distance that I'm looking for. I want this distance, this one, between C and a point here that I don't know. I will call it Q, let's say. So we have here many steps to be done, many steps. What are the steps needed? Actually, we are looking for the distance between C and Q. So we want the measure of this segment, C and Q, from C to Q. We don't know Q. How much is Q? But we know that CQ will be perpendicular on the line AB. So from this keyword perpendicular, we will refer to the slope of perpendicular lines. So the information we have here, that A is negative 18 and negative 14. We have B is negative 3 and 16. So we will find the slope of line AB by applying slope formula. Everyone knows how to find the slope. Okay, so we found the slope. Then what? After finding the slope, we will write so first finding the slope, then equation of the line AB. Equation should be in the form y equals mx plus b. Of course, we can write in point slope form, but we will use this form better for us. So I will use one of the points. Let's use point B, for example. So using point B, I will replace y is 16, slope is 2, x is 3 plus b. So 16 equals minus 6 plus b. So b is 22. So the equation of the line AB is y equals m, yani 2x, plus the new b, which is 22. This is the equation of line AB. Good. So this is the first needed equation. On the other hand, now the distance is perpendicular, we said, right? So we will find now this pink line that is called CQ. We want to write the equation of this line. So what are we going to do for the pink line? Now we will deal with the CQ. What do we have? We don't have the slope, but we know that the slope will be 1 over 2 negative 1 over 2, because the slope of the original line AB is 2, so the slope of line CQ will be negative 1 over 2, the negative reciprocal, because they are perpendicular. And we know that there is a point C that this line passing through, and this point coordinate is 16 and negative 16. So we will write the equation of a line y equals mx plus b. So negative 16 equals negative half times 16 plus b. So b is 8. B is negative 8. So our equation now is y equals to negative half x negative 8. This is the equation of the line, pink one, the CQ. خلينا أكتب, this is the pink one. And this was the blue one. This is for the blue one. But we don't know Q. Where is the Q? Q is the intersection of these 2 points. So to find Q, we need to solve these equations, system of equation. So to find Q, what we are going to do, we will solve equations 1 and 2, either by elimination or by substitution. Actually, we prefer substitution here since both equations were solved for y. So the first equation is 2x plus 22, and the other equation y equal to negative half x minus 8. Yes, this one is the second equation. So since this is y, we are using substitution, combining like terms and solving. Will give us x equals to negative 12. Then replace in any equation to find y. Y is 2x plus 22. X is negative 12 plus 22. So negative 24 plus 2 is negative 2. That means Q now, we now know point Q. So my point Q will be negative 12 and negative 2. And we know already that C is 16 and negative 16. So we are going to find the distance between these 2 points using distance formula. What is distance formula? Remember, distance formula is x2 minus x1 all square plus y2 minus y1 all square. So this is x1, y1, x2, y2, minus 16 minus, I'll start by x2. Put everything in the calculator. You will find it is equal to 14 radical 5, which is about 31.3 foot. So this distance, this length is more than or equal to 20. about the zone, comparing the zoning laws here. So yes, he can do it. And this is the distance. It's a long story, yes, but you should understand the concept. This is the whole solution for your reference. Okay, let's go to do more exercises because this needs more practice, as you know. Let L contains point 0 and -3. So this is line L containing, including 2 points, this and that. And we are finding the distance between point P somewhere here, let's say, and P is 4 and 3. We want to find the distance between this point and the other line. So we are looking for, let's call this point Q, the point of intersection. So as usual, as we have done now, we want Q, we want the equation of a line. So we have long story as well. Let's start by what we know. So we have slope of line L. Done. Now, equation of line L. Use any point. You can use any. By the way, if you can here observe that this is 0 minus 3, so this is B. If you couldn't, just replace it, no worries. I'm taking this point, so -3 is slope 1 times 0 plus B. We end up with B equals -3. So the equation of a line is x minus 3. 1x is x, yeah. This is the equation of line L. Okay, now the other line, which is PQ. Now we are in PQ. What do you know about PQ? We can find the slope. So slope of line PQ. It's perpendicular, so it's -1. We know that point P is 4 and 3, so we will find equation of line PQ. نفس الشيء, same, y equals mx plus b. E is -1, x is 4 plus b, so b is 7, and that means y equals -x plus 7. Now this is the second equation, the blue one. Now, how much is Q? To find Q, we will solve system of equations. So we have two equations. This is equation 1, this is equation 2. We can make them equal to find x and y, coordinate of Q. So 2x is 10, that means x is 5. To find y, replace in any equation. Y is x minus 3, let's say, so y is 2. So the point Q is 5 and 2. So we know now Q. Last step will be finding the distance QP, where you know Q is the one that we found, P is 4 and 3. Now to find the distance, apply distance formula. 5 minus 4 all square plus 2 minus 3 all square. This is square root of 2, approximately 1.4 units. If you know the steps, the procedure will be easy. This is how to find a distance between a point and a line. Remember, the distance is always the measure of the perpendicular segment. Now moving to distance between parallel lines. By definition, parallel lines do not intersect. You know that they are coplanar, they are in the same plane, but they don't intersect. An alternate definition states that two lines in a plane are parallel if they are always equidistant. مسافات متساوية من بعضهم البعض. Between any 2 points, we have the same distance exactly, and usually it's perpendicular as we know here. So for this theory, two lines equidistant from a third, yani it's assuming a line here, x, between the parallel lines W, V. So if line W and line V are equidistant from line X, same distance from here and from there, then definitely the lines W and V are parallel. Now, how to find the distance between two parallel lines? We have actually two types of questions. One is very straightforward answer, has a very straightforward answer. The other one, it needs little work. What if you have here two equations? Each of them represent a horizontal line, as we know. If we imagine how these lines look like, simply you know that y equals to 7 is 1, 2, 3, 4, 5, 6, 7, horizontal line passing through 7. Y equals minus 1 is somewhere here. If you want to find the distance, mentally, you can just count number of units. And if you count them here from 0 to 7, 7 plus another 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 units. In other words, you simply subtract 7 minus 1. So it is 8 to find the distance. So it's just 7 minus 1. Let's say somebody subtracted the other way, and minus 1 minus 7, he will get minus 8. Knowing that the distance will never be negative, just take the absolute value. So just say it's 8 units. Similar situation will be for the vertical lines. Now, x equals minus 6. Everyone now knows that x equals minus 6 is a vertical line. 1, 2, 3, 4, 5, 6 from the negative side. So it's negative 6 somewhere here. X equals to 5. 1, 2, 3, 4, 5. It is here, over there, passing through 5. And if you want to find the distance, which is this horizontal length between this and that, it's 11 units. If you count from minus 6 to 5, you will find 11 units. Or in other words, it's 5 minus 6, which is 11, or you can say minus 6 minus 5, absolute value of negative 11, which is 11 units. Okay. Now, the last exercise I'm going to solve with you is also distance between parallel lines, but not horizontal. How do we know that they are parallel? As you see, this has slope 3, other one has slope 3, but each one has different y-intercept. So if you imagine how these lines look like, you can imagine that one of the lines is passing through 0, 0, and the other one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the other one is passing through 10. How do I know? Because the y-intercept here is 0, the y-intercept here is 10. So this point is 0, 10. This point is 0, 0. Both of them have same slopes. Of course, I'm not very accurate in drawing, but this is how it looks like. Now, if you want to find the distance between these two parallel lines, imagine that you are extending a line from one known point to the other, but in a perpendicular way. So we are looking for this segment. And as usual, I will assume the point of intersection here is Q. So what shall I do? This is my first line. I will write this is y equals 3x, and this is y equals 3x plus 10. Now, this is easier than the previous one because here we have ready equations already there, but we need to find the equation of the red line. The red line has a slope equals to how much? Since here the slope from this equation, slope is 3, the perpendicular line, which is the red one, I call it here PQ, has a slope is negative 1 over 3. So this one has a slope negative 1 over 3. Okay. Now, how can you write the equation of a line, equation of the red line, which is the perpendicular part? Line having a slope 1 over 3 and passing by the point 0, 0. As usual, y equals mx plus b. I will choose 0, 0. So 0 equals to slope is negative 1 over 3, 0 plus b. So b is 0. So my equation of the red line, y equals the new slope plus the new b, which is 0. So this is the slope of the, the equation of the line, the red line. Okay, now this equation is y equals minus 1 over 3x. I want now the point of intersection, which is Q. How much is Q? Q is the intersection of y equals negative 1 over x, 3x, and the other one, y equals 3x plus 10. And as we have done in the previous exercises, we will solve the system of equation. So I will make them equal. If you solve, as usual, multiply by 3 over 10 both sides. So x is negative 3. When x is negative 3, use your place to find y. Use any equation. I will use y equals negative 1 over 3x. So y is negative 1 over 3 times negative 3, which is 1. So I have here the point Q that I'm looking for is minus 3, 1. Right? Minus 3 and 1. So minus 3 and 1, we have here 2 points. Point Q is minus 3 and 1. The other point is P, 0, 0, using the distance formula. And of course, you can do it in details, but... And the answer will be square root of 10, which is approximately 3.16 units. So that was the last question related to parallel lines. What if here you have find the distance between or from the line to the given point? Now, line y equals minus 3. Now everyone knows that it's a horizontal line passing through minus 3. And a point 5,2 will be somewhere here. Let's say 5,2, somewhere here. As you see here, you will find direct distance, and it will be just the difference between y coordinates. So it is 2 minus minus 3, which is 5. Easy. Here, it's a vertical line. So here, let's change the color. Vertical line passing through 4. And negative 2, 5, somewhere here. So you are finding this distance somewhere here. Let's extend this line. So we are looking for this distance, length of the red segment here. So simply, you just subtract the x coordinate, because here x is x equals 4, and this is negative 2, 5, so x is negative 2. So as if we are finding the distance between 4 and minus 2. So it is 4 minus minus 2, which is 6 units, all in units. Easy. Now, what if the situation is different now? Now, we have a line with given equation and a point which is negative 6 and 5. Let's call it P. How can I find the distance? So this is the distance that I'm looking for. Again, I will call this point of intersection Q. I need Q. I have to have Q. How can I find it? I need the equation of this line. So to find the equation of this line, I need slope and a point. I have a point which is negative 6 and 5, but I don't know the slope. But I know that the slope of the given line is 1 over 6. So the slope of PQ will be the perpendicular slope, which is negative 6. So now we want equation of QP. What information we have? We have slope is negative 6. We have point P, negative 6 and 5. So I can write y equals mx plus b using the same procedure that I have done before. So b is negative 31. So my equation of a line will be negative 6x minus 31. This is the equation of the red line. As usual, I will try to find Q. To find Q, I will solve equations, equation 2 with equation 1. So 6x plus 6 equals negative 6x minus 31. And when you solve, you can solve directly. It will be x equals negative 6. Replacing in any equation will give you y equals to 5. Now, the point Q is negative 6 and 5. And point Q was negative 6 and 5. Surprisingly, 2 points are located on each other. Yani it's the same point. What does that mean? That means the point is on the line. That means the distance is 0 units. And this is a special case. Yani the point was on the line. There's no space between the point and the line. I hope now it's clear for everyone. Thank you for watching. And please answer the survey question that I have attached in the previous video. Thank you all. See you. إلى اللقاء.